this section, we're going to cover general simplex problems. And the key thing we need to make sure we understand is the difference between general simplex and standard simplex. In the previous section, we talked about standard. And there may be some problems, or for example, in the real world, where you're going to pull up a computer program that may reference one or the other, especially in coding, where you need to know what code you're looking at. And so it's important you understand which one we're working with. So standard had the requirement, these three requirements, if you remember from the previous lesson. What's the point of general? Well, two of the three are going to get knocked out. It's going to be a lot less restrictive. The negative to general simplex is there's more steps. So if you were writing the computer program for it and you knew it was a standard problem, you would not want to execute the general part of your program because it would waste time, it would waste code. So you want to just keep it as simple as possible. So what do we get rid of? Well, it no longer, with general simplex, it doesn't have to be a maximum. It could be anything, a max or a min. Okay, and also there are no restrictions on our constraints. So the only thing that's left is the real world constraints. The only thing that's left is all of our variables just have to be talking about positive numbers. So again, no negative amount of cars are allowed to be made. Let's see, steps for using standard simplex method. The idea here is we're going to do steps 1 through 6, and we're going to keep doing them. Repeat the process. You'll notice right here, steps 1 through 6, we're just going to keep doing these over and over and over, just like we did with regular simplex, until there are no negative solutions, and you'll understand what that means in a minute. And then notice all it's going to do is turn it into a standard simplex problem. So now, once you're done through 1 through 6, now you're just going to do the exact same process you did in the last section. So if you didn't master regular simplex, you need to go back and practice that, because you can't do any of these without doing those. Okay, so here we go. Let's do one. We'll keep popping back and forth between the steps and the and actually doing one. So first things first, I created this problem, and I gave us a little graph to make it a little easier to shade and kind of look at. So let's quickly mark this up here. And notice I put the equations here to help us understand the color coding. So this one is A, the red one is A, then the green one should be B, and then the blue one should be C. There we are. Okay, now let's do shading. The red one is shading. Well, if we do the test point of 0, 0, so 0 is greater than or equal to 6. That would be false. So the red one is shading up. Okay. Actually, you know what? Brilliant. I have a red pen. Why don't I use it? There we go. Okay, so the red one is shading up. All right. The next one, the green one. The green one is shading with 0 is less than or equal to 4. That would be true. So the green one is shading towards 0, 0. So that would be true. So we're shading this way. Oop, I think I already see where our region is going to be. And then for the blue one would be 0 is less than or equal to 8. That would be true. So we're shading this way. So our shaded region is this triangle right in here. Now, how a general simplex problem is different than every one we've done up to this point is every other one we've done in standard, 0, 0 was one of our potential solutions. It was one of our corner points. Because we have a problem that is greater than or equal to, a constraint that is greater than or equal to, whereas since that one's shading up, it removes 0, 0 from our constraint. So therefore, it changes our thought process. The idea before was you were going to start here and look around and decide which direction was the steeper slope, which direction do we want to travel in, right? Well, now what we're going to do is set up the problem like we would as in a normal matrix, just like we would with standard simplex. Okay, so and then we're gonna go through a thought process that's very similar, looking for slope. But what we're going to do is, before we were worried about what would make the answer better. And I don't care right now, because I don't care if going to the right, going to the x-axis, or going to the y-axis is going to make my answer larger or smaller, because these aren't feasible answers anyway. So we just got to set up the problem, and we have to make it. We have to start walking to our solution region. So that's going to be our first thought process. So let's set up the problem. let's set up the problem. How do we do it? Well, maximize the exact same way as before. Negative x minus y plus p equals 0. That's right. Standard simplex, uh, you need to leave your p, your maximize constant, with a positive leading coefficient, and then all your other values come across to make it equal to 0. Okay, now here's the only little twist, but again, it's the exact same thing as before if you really understood what you were doing. How do I do this? I need to take my objectives and I need to change them to equal to's. And I need to put in a slack variable. Now, if you were just constantly adding a slack variable but not really thinking about why, you're going to get it wrong. If you understood why we were adding a slack variable and you understand the little twist here, try it. Pause the video. Okay, so what we're saying here is this stuff on the left has to be bigger than 6, right? So for me to make something, if something is bigger than 6 and I need to make it equal to 6, I can't add a variable. Adding would make it even bigger. I need to subtract a variable. That's it. That's your big change. So in problems, they were always adding. Well, now they have to either add or subtract. You just have to look at the values. So, all right, so this one, because this is less than, the stuff on the left is less than, for me to make it equal to, I need to add. I'll use a Q, I don't know. All right, and then for this one, 2x plus y equals 8. Once again, if you're getting this, ask yourself, pause the video. Okay, so this is less than, which means the stuff on the left has to be smaller, which means if I want it to be equal to, it needs to be adding. All right, there's a T. And all right, we are ready to go. So let's now set this up into a matrix. And notice you can still use the pivot website to help you. So setting it up is just like before, same thing as before, which say it's X, Y. These don't have Z's, okay, so it's just X and Y. R, Q, T, P equal sign. Okay, first equation is 1, 2, negative 1, 0, 0, 0, 6. Next one is negative 1, 1, 1, sorry, not 1, 0, 1, 0, 0, 4. So you'll see there is nothing different here, right? This is all the same as what you're used to if you've done standard simplex, which is kind of nice. All right, so then down here we have negative 1, negative 1, 0, 0, 0, 1, 0. All right, here we go. Step 1, complete. Set the problem up the exact same way you know how to. The only difference was watch for those negative slack variables. Okay, step 2. Step 2. Here we go. Star any row that has a negative solution. What? Okay, well, all this means is we're picking a direction. What we're going to do now is we're going to say, I want to walk toward one of my equations. And what the thought process is, well, what equation messed me up? Which equation is shading up, not down? And because we haven't done any pivots yet, you can tell me, hey, it's equation A. I know which one it's going to be, right? It's the red one. But if you had lots of equations that were shading up, or if we had done a pivot and you had walked to one intercept but you haven't, and then you're now looking around, your logic maybe changed a little bit. So the process is always the same, even though right now we know which row we're going to star. We're going to star the first row because it has equation A, because that's the one that is keeping us from the solution region. But here we go. So the logic is, read your answer right now just like you would finished a standard simplex problem. So remember, the idea is if there's lots of numbers in a column, that thing immediately becomes 0, right? That's what we're going to do. We're starting off with that. So x equals 0. Now, I don't want to scratch it out because I need these numbers. So we're just going to talk through it. So this would be 0, x would be 0, y would be 0, r we're going to keep, q we're going to keep, t we're going to keep, p we always keep, equal sign we always keep. All right, here we go. So the first row would give me the result of negative r equals 6, which therefore means r equals negative 6. Now, this is a huge flag. This is a huge no-no. Why is this so bad? Well, we have the rule that all of our variables have to be greater than or equal to 0. This one is not, which means this is telling us is this is keeping us, we are not in the solution region because of this row. So we put a star by it. This row is keeping us out of the solution region. The next row, would be what? So the second row here would be what? 0x, 0y, 0r, q is equal to 4. Now that one's fine, right? That one's not causing us any issues. Okay, and then the last row would be, if you're keeping up, you can do this in your head a little bit, t equals 8. That's fine, right? It's positive. That's all we really care about, positive or 0. And then the bottom row we always keep. That's our objective equation. So there we go. That's the first row gets a star. And that is step 2. Star any row that has a negative solution. Done. All right, step 3. Step 3. Step 3 says pick the largest positive value in any of the starred rows. Okay, so what we're doing is, again, we're looking for steepest slope, and that's what all these are saying is the x has a slope of 1, the y has a slope of 2. So what we're doing is we're looking in this row for the steepest slope, and that would be 2, right? We're looking for the direction in which we should walk that's going to get us to that equation the fastest. So if you were to look at it graphically, you'd walk up this way, and now notice these are 0.5 steps, not ones. So 0.5, 1, 2, looks like it around 2, around 3, right? Where if I was going in the x direction, I'm going to run into my first intercept, well, and especially to that red equation at 1, 2, 3, 4. I don't, yeah, these are like 1 points, whatever's, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like not even close. Or if it's 0.5, it still doesn't matter. Not even close, right? Way further out. So y is the faster direction because it has the steeper slope. It gets us there faster. All right, now that's it. So all step 3 is asking you to do is find the largest positive number in your starred row. That's it. Okay, next, use the ratio test in the column from the value in step 2 to determine where to pivot. All right, translation, just like standard simplex, what we have done is picked our column. We said this 2 has the largest value, so now I'm going to pivot in this column. So I still check my ratios just like we do in standard simplex. 6 divided by 2 equals 3, 4 divided by 1 equals 4, and 8 divided by 1 equals 8. So now we're going to pivot at the smallest ratio, because what we're doing is we're saying, which y-intercept do I run into first? Which y-intercept do I want to stop at and see, am I now in my solution region? So I walk in the y direction until I reach this intercept. Notice this is our red equation, which therefore means it has the first y-intercept, which we just verified by doing the ratio test. And so we're going to walk there, we're going to stop, we're going to pivot, and then we're going to see, do we have any negative solutions? Am I now in my solution region? So we don't need any of those ratios, we don't need any of that other stuff. We just pivot like normal. So you can use your pivot website if you like, but let's write down our pivots. The pivots would be, and remember, you have to use row 1. So I need negative row 1 plus 2 row 2s to make a new row 2. Okay, then we need to do a same calculation, negative row 1 plus 2 row 3s to make a new row 3. And then finally, for the fourth equation, I need what? Leave row 1 alone, plus 2 row 4s to make a new row 4. Right? We're just doing elimination technique. So that's what we would do by hand. So we're going to go ahead and pop this matrix into here. I'm going to pause the video. Okay, so now you have put your equation into the matrix. Don't forget in your website to change this to integer. It's how we would do it by hand. Okay, now we decided we're going to pivot in the y column in the first row on this 2. So now we're going to click there, click pivot on selection, and this gives us our new matrix. So now, again, copy this matrix down onto your paper, and you can see, let's see where we are in the problem. Let's see what our next step is. So I'm going to pause the video again while I copy. Okay, so now we have copied down our matrix. Now let's read it. So we rinse and repeat. So we're going to go back to our steps. and we used our row operations around your pivot for step 3. Done. Okay. Now repeat the entire process to see until there are no negative solutions. So now we're going to go back through here and see when I read my answers, do any of my values give me a negative number? So we read like normal: x equals 0, y we're going to keep, r equals 0, q we're going to keep, t we're going to keep, p we're going to keep, equal sign we're going to keep because we always do, and we always keep p as well. All right, so now let's read across. X is 0, so I've got two y's, r's are 0. Let's see, 0q, 0t, 0p equals 6. I really don't care what the number is. I just care that it's positive, but you'll see y equals 3. So this one was giving us the value of y. Okay, so the next row, when we read this, we got x equals 0, y equals 0, r equals 0, q. So it's going to be 2q's is equal to 2, which means q equals 1. Fine, it's positive. Okay, that one gives us a q. Last row, let's see, x equals 0, y equals 0, r equals 0, q, that's a 0. T, so 2t equals 10, so that gives us t equals 5. Good news, that gives us t. So therefore, I have all positive numbers. That means I'm done with the general part of the problem. And what that really means is that we have now reached our solution region, which we saw graphically. Looking at it, we knew when I walked in the y direction and reached this point, I knew I'd be touching my solution region. So now what this means is start pivoting. Now we're going to walk to a corner. We're going to walk to one of our corners. We're either going to go to this one here, or we're going to go to this one down here, because that would be the closest directions, where we trace around the outside of our shaded region. But we're going to walk to a corner and test it and see if it's the best. And how do we do that? Just our regular good old simplex problems. So how do we test that? Well, if you look here, all right, I got -1, -1, and if you haven't figured it out yet, what do you do if there's a tie? Well, what would you do if you're standing at the bottom of a hill and you were looking up the hill and you said, which path should I take? They're both the same steepness and I want to get up as fast as possible. Well, obviously you would stand there and agonize about it for hours, right? No, you just pick one. Just go in a direction. So let's choose X. We'll use the X column as our pivot, but you could use the R column as your pivot if you wanted to. And somebody will ask me, I am sure, or is wondering, well, is one of them better than the other? Yes, one is. We don't know which one. There's no way to tell. And when you're doing this in a computer, you don't really care anyway. The computer will whip through it fast enough that you just pick one and you go with it. So let's go in the X column. So that means we now need to test our pivots. So we're going to have 6 divided by 1, which is 6. 2 divided by -3, I can toss out. I don't even care because it is negative. There we go. And then this last column is 10 divided by 3, which is smaller than 6. So therefore, our pivot is going to be there. And what is 10 divided by 3? 3.3 and change. All right, so anyway, we're done with that. So there is our pivot. So we bring up our handy dandy little website, and there we are. We said we are going to pivot right here on the 3. So we're going to pivot right there. And now you'll see we have all sorts of fun new numbers, and rinse and repeat. Now, at some point, I am okay with you not writing these things out anymore, but you need to know the process, because on the test I'm going to ask you to pick a pivot. I'm going to ask you to write your row operators. So you do need to be able to say, okay, so this is row 3 plus row 2 to make a new row 2. The top equation would be what? Negative row 3's plus 3 row 1's to make a new row 1. And finally, we just need row 3 plus 3 row 4's to make a new row 4. So your answers will be something like this. Write your row operators, or put a box around your pivot, or something like that. Okay, so it's fine. If you say, I don't want to copy down the whole matrix, I've got this, then don't. You don't need to. So if you did your pivot and you don't want to copy it down, if you can just see it from this perspective and say, okay, look, I'm still checking for the largest negative value in my objective equation. This is standard simplex. Okay, it's in the R column. Now, in the R column, I test my ratios. 4 divided by negative 2, not negative. 6 divided by 1, 6. 10 divided by 1, 10. 14 divided by, oh, nope, that's the objective. We don't need that one. So it's either going to be 6 or 10. Hey, 6 is smaller. I'm pivoting right there. Then knock yourself out. Go for it. I'm going to copy down the matrix just for the notes for somebody who isn't getting it that quickly, but I understand it's fine if you do it that way. Okay, I have copied down the matrix, so now I'm going to put in the row operators. So for anybody who's testing themselves on that, pause the video. And while I was writing these out, it dawned on me. Somebody may be saying, well, I did the same row operators, or I did run my row operators that would have resulted in one right here and 0 everywhere else. But I did differently. Well, what is my logic? Professor Dwork, my logic is I always do this. Notice I always start with row 2 first, the pivot column, because every equation has to have the pivot in it, the pivot row. So everything has row 2. Then my next bit of logic is if I need to make something negative, I always make it my pivot because I'm always trying to keep these values positive in my equal sign. That way it's easy to see positive and negative ratios. It's a lot less to keep track of. And my less than or equal to's and greater than equal to's would all keep their same representation from the original. In these particular problems that we're doing, it doesn't really matter, but that's the logic. So I always, if I need a negative, my pivot row becomes the negative, and then I multiply by whatever value needed otherwise. Okay, so let's pivot. Let's pivot. So we wanted to pivot right here, right in the R column, second row. We're going to pivot on that selection, and we're going to look across, and we're going to do a happy dance because notice there are no negative numbers, which means we're finally done. So we read our answers. So this means, let's see here, the X we're going to keep, Y we're going to keep, R we're going to keep, Q is gone, T is gone, and so on and so forth. Okay, so let me sneak this to the side and work a little dual screen here. So if I was reading across my row, we've got what? 3 Y's is, and then Q, that's 0, 0, 0. So 3 Y's equals 16. So Y equals 16 thirds. All right, next one, next row. R is going to equal 0, 0, 0, 6. We don't really care, it's a slack variable, but it does if you wanted to. And then we have 3x is equal to 0, 0, 0, 0. Sorry, let's try again. 0, 0, 0, 0, 0, 4. So x equals 4 thirds. And last but not least, 0, 0, 0, 0, 0. 3p is equal to 20. So therefore p equals 20 thirds. So what do we say? Well, then that means we have a max of 20 thirds at x value of 4 thirds, y value of 16 thirds. And there we are. Okay, I hope that helped. And again, that same website that we used before to check our work, it can also help us with this. It's the same process. Just type it in with less than or equal to's or greater than equal to's, and you'll get your answer. All right, I'll see you in the next video.